Hi, and welcome to data science interview preparation session. We're talking about question six. Six is about regression versus classification. The question you may probably ask it is, can you explain the difference between regression and classification? If you are invited for an interview and you may ask to answer this question, can you explain the difference between regression and classification? First of all, we have divided algorithms into two groups. You can watch the previous interview question about supervised versus unsupervised learning. So algorithms can be divided into groups: supervised versus unsupervised learning. Supervised learning algorithms use labeled data as input, while unsupervised learning algorithms use unlabeled data. However, we can distinguish machine learning algorithms by the output they produce. In terms of output, two main types of machine learning models exist: those for classification and the other for regression. So the regression is used to predict outputs that are continuous variables. Only regression algorithms can predict the continuous variables. The outputs are quantities that can be flexibly determined based on the inputs of the model rather than being confined to a set of possible levels. For example, predict the height of a potted plant from the output of rainfall, and predict salary based on someone's age and availability of high-speed internet, and predict a car's miles per gallon based on size and model year. The most popular algorithms of regression is linear regression. It's the most popular regression algorithms. It is often underrated because of its simplicity. In a business setting, it could be used to predict the likelihood that customer will churn or the revenue a customer will generate. More complex models may fit this data better at the cost of losing simplicity. So the linear regression is the most popular regression algorithms. While classification is used to predict a discrete levels. A regression used to predict a continuous level or continuous variable, while classification is used to predict a discrete level. The outputs fall under a finite set of possible outcomes. Many situations have only two possible outcomes. This is called binary classification. The possible outcomes of binary classification is true or false, 0 or 1, or not. And for example, predict whether an email is a spam or not. A spam classification is one example of classification. So whether the incoming email is spam or not, it can predict. And also predict today will rain or not. Today will rain or not. Predict whether a user is a poor user or not. This kinds of examples are classification examples. So because we possibly produce the two possible outcomes. The possible outcomes either not or. And multi-level classifications, not only binary classifications, we may have a multi-level classifications is when there are multiple possible outcomes. If we have multiple possible outcomes, we are going to use multiple or multi-level classification algorithms. For example, it is useful for customer segmentation. Customer segmentation is one of the multi-level classification. Image categorization, it may have multiple possible outcomes, and sentiment analysis for understanding the text. For example, tutors. We can simply analyze the tutor tutors and we can understand about that tut. So to perform these classifications, to perform the multi-level classifications, we use models like naive Bayes, k-nearest neighbors, and support vector machines. So choosing a model is a critical step in the machine learning process. It is important that the model fits the question at hand. When you choose the right model, you are one step closer to getting meaningful and interesting results. Thanks for watching.